want to take a look at a couple examples in using the quadratic function in the expanded form. We want to be able to identify some things and potentially graph this quadratic or this parabola. In this one, we want to find the vertex, the axis of symmetry, and the max or the min value of this function. If it's x squared plus 10x plus 23, one thing I know for sure is it's going to be an upward opening parabola because this is positive up here. Now the vertex is important when I'm graphing it because it's that turning point. It's a key place. So I want to know what that is. I would use the formula x equals the opposite of b over 2a. So that's going to be the opposite of 10 or negative 10 over 2 times a 1. Since there's no number, I know that's a 1 there. That simplifies to a negative 5. That's only half of my vertex. The vertex is an ordered pair because it's a point on the graph, so I have to take this negative 5 and plug it into my function. Right? So negative 5 in place of these x's here. Negative 5 squared is going to be 25, plus 10 times negative 5, or minus 50, plus my 23 will result in an answer of negative 2. So the x and the y, negative 5, negative 2, is my vertex. What's the axis of symmetry? Well, it's just the x equals equation, x equals negative 5. All right, and that's the vertical line through the vertex. Now, is it going to be a max or a min? Well, we said it's going to open up, so that means we're going to have, if it opens up, we're going to have a lowest spot. We're going to have a minimum, and it's the y value at my vertex. So the minimum is the negative 2 at a negative 5. Let's take a look at another one like this. If I have a negative x squared plus 14x minus 47, that opens down. Okay, so that means we're going to end up with a maximum on this one instead. Finding the vertex, I'm going to go through the same steps. Minus b, or opposite of b, over 2a. So in this case, I'm going to use a negative 14 over 2 times negative 1 because that's a negative x squared there. That simplifies to a 7. So I take the 7 and I plug it into my function up here, work out my answers. Now notice what we do here. Order of operations says you got to square before you can multiply by that negative. So this becomes a negative 49 plus the 14 times 7 minus the 47. You should get a 2 for that. So the vertex is the x, y, or 7, 2. Does it have a max or a min? Well, we said it opens down, so it's going to have a maximum. What is that? That maximum is the y value here in my vertex, the 2. Okay, so I've kind of sketched a parabola here, a downward opening parabola with a vertex of 7, 2. And their next part is asking me to find the range. Well, the range, remember, are the y values associated with your picture. And you always do it in numeric order, so we're going to start with the lowest y values that we would see. These arrows indicate that the parabola goes down forever, so the lowest ones would be negative infinity. And we're going to see the graph until I get up to this level on my y-axis, and then the graph stops, right? It doesn't go any higher than that. What is that y-coordinate? That y-coordinate's a 2. So my range is negative infinity to 2. Now what about intervals of increase and decrease? Well, that's where we're reading sideways and we're trying to decide if it's moving upwards or moving downwards as we move from left to right. I've drawn in the axis of symmetry, that vertical line there, because that's the change point, the turning point. Everything from the left side up to that line right there, which is at x equals 7, all of this is increasing. The parabola is going upward as we move. So negative infinity to 7, and here we never include the endpoints on these intervals, increase, decrease. Decreasing, well, that's going to be from this axis of symmetry forward to positive infinity. All these x's here are part of the parabola where it's going down.